everyone, and welcome to Let's Talk MLOps. My name is Becky, and I'm on a mission to find out the latest trends, challenges, and prospects within machine learning, and with a particular focus on machine learning operations, or MLOps. Throughout this series, I'll be talking to experts within the field who will share their knowledge as well as advice for implementing, monitoring, and scaling successful machine learning practices. Hello everyone and welcome to Let's Talk MLOps. Today I have the absolute pleasure of being joined by Anders Blankholm, who is lead MLOps engineer at Charlotte Tilbury Beauty. He's previously shared his wisdom at conferences including the Rework MLOps Summit in 2022 and is also an advocate for diversity and inclusive culture. Anders, thank you so much for joining us today and sharing your knowledge.
Thank you very much. Hello.
Hey, all right. Okay, so I think a really nice place to start would be if you could tell us a bit about your personal journey into MLOps. You know, where did it start? When did it start? And how did it happen?
Sure. I guess it initially started at university, which is in another age. I wanted to take a course in AI, but at the time we hadn't quite had the renewed interest in AI that we're seeing today. And the courses were a little outdated and I actually skipped it. And then somewhere later in life, I became a backend engineer and I joined ASOS.com on their recommender system before it was AI based. And at that time, that was about 2017, ASOS was just starting to build their own sort of AI department, if you will. And I sort of had a renewed interest in AI because AI was blossoming again. And a lot of my side projects had to do with more generative stuff than business stuff. But I was showing interest again, and I started hanging out with the AI crowd at ASOS. And after about 6 months, they took me in because they needed engineers. They didn't have any. So I sort of like transitioned from being a .NET engineer who just mostly did backend stuff to trying to figure out how we scale deployments of ML. And back then it wasn't as set in stone and clear as it is now. In particular, nobody was really talking about it outside of the FAANG companies, and they sort of had it figured out, but no sort of like smaller but still large corporations were talking about how you do this at scale. And ASOS is all Azure based, so certainly nobody was talking about how to do that in the Microsoft cloud, and that became my task along with a couple of other engineers. And it focused on transferring this recommender system that we had over to being science-based, which mostly fell to some scientist colleagues of mine, and then trying to get it out there in front of a lot of people and to have it work quite reliably and scale and all of that. At ASOS, by the time I left, the recommender system at peak load would often receive 3,000 requests a second, right? So you need to be able to, you have to do that at low latency as well, which means you can't just deploy in Britain where all of the ASOS customers are based and they have a great experience. You also have to do deployments in the US and in Asia and so on, so that all of the customers around the globe have the same experience. It requires load balancing and all other such things. And we leaned on Kubernetes early on, which Azure had only just introduced Kubernetes. So there was a lot of quirks that had to be ironed out. And I think a third of the security patches every single time for about 6 months were from us, like there were issues that we had brought up. So that was a lot of fun. And after a while, we got the online recommender system and so like the stack for online ML quite well figured out. And then we realized we hadn't done that for offline ML, so for your batch jobs and whatnot. And I transferred over to look after the engineering for 3 teams that were doing that. So that was the growth or marketing ML team, the forecasting team, and the pricing team. I did most of my work in the pricing team, but I helped out in the others. And for the last 2.5 years of my job there before I moved on, I was sort of like designing the offline machine learning stack, if you will, for ASOS.com. And then I transferred to Charlotte Tilbury Beauty very recently in, I think it was September of last year, or August. can't remember exactly. Been there a few months, and I'm doing essentially the same thing, taking all of those lessons that I learned at ASOS and implementing them again, not just on the stack, but I also like to get into how you build teams and how they should work together and how they fit into the organization and such. And I'm sort of like just taking all of those lessons with me and building a machine learning stack from scratch for Charlotte Tilbury Beauty now.
Okay, awesome. And for those, I know you probably slightly described bits of it there, but for those who aren't yet familiar or still learning about MLOps, how would you define it?
Well, me being the key there, I guess it's a buzzword and it means a lot of different things to a lot of different people. So you often have to be aware, particularly if it's for employment, you have to read a little bit into the job description and be quite diligent in your interview to understand what it is the business really wants from you. To me, it's how all of the things that you have to do in order to ship science faster. That's as simple as I can make it. But there's a narrow view, which is what are the technical components you need. So in that narrow view, you tend to be concerned with continuous training, which is, usually when you develop a model, you've got some data, but once it's actually going to be operated, which is the key word in ops, right? You probably need to keep feeding it data because data will keep arriving in a lot of cases, at least. There's things like not just feature engineering, but making feature engineering efficient. So there's things like feature stores and other approaches in that space. Experiment tracking is quite important so that, a lot of the time a scientist will run a lot of different versions of the thing that they're doing. And then they'll go, oh, well, the thing that I had on Wednesday was actually really good. And the thing I have now is not particularly good. How do I get back to Wednesday? So experiment tracking helps you take care of that issue. It allows you to do time travel back and forth and sort of captures everything that you're doing around that. Then once your model is actually deployed, aside from the serving infrastructure or the job infrastructure, if it's not a live facing thing, you probably want a lot of observability tooling, things like logging, monitoring, alerting, and explainability, your dashboards, if you will, to keep an eye on the thing. You don't just want dashboards because dashboards require you to look at them, and a lot of the time people are busy. So you generally want alerting that comes to you and tells you something is wrong. And then there's things like artifact management, right, where we build all of these models. Where should they live? How do you version them? How do they go there? And how do you make sure the right version gets to the customer or gets deployed? How do you have controls for rolling back if it was the wrong one, and all of the stuff around determining what is the right version, when you have challenger models coming along, and that goes into model registries and stuff of that nature. Those are like the very technical bits that you kind of need in order to quote unquote operate a model. There are a few misconceptions as well. One of the big ones for me is that people tend to think that it's just about operationalizing machine learning, but you'll find that it's very hard to do that unless you also tackle access to data and compute. And those are often thought of, at least in big organizations, they're often thought of as jobs for the data engineers or whoever else in your organization might be handling your cloud infrastructure. I at least think that that's also a job for MLOps to sort out, not just for the engineers, but for scientists as well, making the access to the data and compute smooth and easy and also secure.
Does that make it kind of a mix?
Sorry, go on.
No, I was just going to try and, from my not so engineering background, in my head, does that sort of make it a mix then of, machine learning, engineering mixed with DevOps, maybe mixed with data as well? Is it sort of those three from the way you sort of explained it there? Is that fair, more or less? Sort of those three parts?
Yeah. And we have a new field that's burgeoning now called data ops as well. So that's sort of on a very similar bend. In fact, a lot of the things that are going on in MLOps are just traditional DevOps stuff that's being brought into an ML context. The problems start to arise around where traditional ops people think that that's all there's to it, and then they don't realize that ML applications are quite different to traditional software applications, and there's some very special challenges. But aside from that, it's a lot of the same stuff that's just in a new context. I also like to take a broader view of MLOps. I don't like to think of it just as the technical bits, because my go-to saying is, shipping science faster. And
that should be their tagline: MLOps, shipping science faster. That would work, right? That would.
Feel free, steal it. I don't mind. That's just my philosophy about it. And you'll find that if you have all of the technical bits, often it won't necessarily help that much. There's things like making the workflows for scientists friction-free is quite important, and all of the things that go with that. And it's also building an organization that's well-oiled and oriented towards shipping intelligent products. Often the ML function is sort of like tacked on. There hasn't been a whole lot of thought put into how the organization should work around it. Typically has very little support. It's often an island, or not even, like, the wider company doesn't even know that they exist. This is a really common thing that comes up, at least in large corporations. And to that end, you want to make sure that you have a really good structure for deciding which kind of problems you want to work on, who owns that, and then which order should you work on them in, because you're not going to be able to do all of them at the same time. And then, who's responsible for making sure that they get shipped, and how do we capture all of that along the chain, and how do we make sure that as ML people, we're a good citizen in this ML solution shipping ecosystem, right? We have our data people upstream usually, but they also tend to be downstream from us, because stuff that we produce needs to go back into the data estate. How do we play nice with them? How do we make sure that we don't pick tooling that is entirely foreign to them, so that we can, speak the same language, if you will?
Yeah, I mean, that I was going to say, it sounds like that other side, sort of the less technical side, is that sort of collaboration focus. It's very about being collaborative. Is that right? Sort of from how I've understood it, and facilitating it. Yeah.
Yeah, exactly. And that doesn't have to be something that the MLOps or ML people do. It's nice if you participate, obviously, but it's just important that there are someone who owns that role, if you will. And I think the crucial thing that I've noticed is having someone, we tend to call it a technical product owner, right? Or a data product owner, if you will, which is a person who can speak to the business and understand what the business wants, and then translate that into what the ML people ought to be getting up to, in which order. And then they can also translate back the progress and the challenges that the ML team has to the business, so that, there isn't this very classic and typical communication breakdown.
Yeah, of course. Thank you. That's a great in-depth definition. And what would you say are the main, because there may be a few sort of challenges that are currently within MLOps, either general ones or ones that you're seeing specifically in your team, and how are you working to solve them?
I think generally with MLOps, a lot of companies are struggling with, or actually I'd see them going wrong quite a lot of the time, with understanding or being honest with themselves about which level of MLOps, if any, is appropriate for their context. And what I mean by that is, there's a lot of startups that has like one ML person. It's typically a scientist who's working on some algorithm that, whatever the product is supposed to achieve. Going in heavy MLOps for that person is probably a waste of their time. That's not to say that there's not a lot of MLOps principles that can benefit them, and a lot of the tools that they could use.
Yeah.
But saying that there needs to be a big focus on MLOps for that person is probably a mistake. And I think even scaling up that team quite a bit, there's still quite a ways until you need all of the things that are in MLOps. For example, one of the things I often see is tiny teams starting out going, we need a feature store off the bat. How about you develop a few solutions and then do some feature engineering and see whether or not you need the feature reuse or not that feature store brings, or whether you need the quote unquote caching capability that you get out of a feature store when you're live serving something. I think that's a pretty big challenge in general. I also think keeping up with the pace of the bleeding edge. So we're always, this field is moving very, very, very quickly, right? There's, you want to be competitive as a business and in developing an ML product. Often you need to be reading the papers that are coming out and then trying to either if they come with code, that's great, but often you need to implement them yourselves, right? And for MLOps, that brings a few challenges, which is often architectures are changing very quickly. It's very common. Let's take the case of a recommender system, right? And you want your recommender system to be as good as it can possibly be to be competitive with your competitors, if you will. You want it to be better, right? And ideally also to have the business increments that you can get out, as much of them as you can get out of it from a business perspective, right? It's very common that a new paper comes along that uses a different model architecture to the one you currently have, and it's quite a bit better. And at this point, it is very common that you then switch to that architecture. Or as an MLOps person, you're responsible for making sure that the infrastructure can handle all of that. Right. And I see very often that people go into, when they're designing the ML stack, if you will, they design it very narrowly for the cases that they have right now, with no window for what might it look like down the road. And there's something to be said for premature optimization, and you shouldn't generalize unless you actually have a use case. But there are things that you could do in picking frameworks that have more generalized approaches than ones that are very locked down. I can give you a very good example, which is, let's say, something like TensorFlow serving versus Kubeflow. So TensorFlow serving, if you use that, at least last time I checked, and that was a few months ago, so I may be a little out of date, but at least at that time, if you use that, you need to implement everything in pure TensorFlow. That's not necessarily a nice experience for your scientist, and also it doesn't support all of the scenarios that you might have. It's great if you're all into TensorFlow, but it's not so great the moment you need something else. Whereas Kubeflow and Kubeflow serving, for example, is basically just an abstraction over the top of Kubernetes that supports most of the mainstream frameworks, and you have an option of falling back to custom jobs or whatever if whatever they have for the typical or popular frameworks isn't to your liking. So basically, Kubeflow, like choosing something like Kubeflow over TensorFlow serving is a choice that you have to think about upfront, right? Because you need to be aware that down the road, you need to be able to have as much model architecture flexibility as you can possibly give, because you never want to be the one who's constraining your scientists and how they're able to express whatever task, solution to whatever task it is that they're working on. So that's a fairly large challenge, is keeping up with the pace and sort of like trying to predict, even though prediction is a bit futile, but trying to like see where you might land and trying to make good choices for that. I think also a very large challenge is people and lack of them in general. We were struggling to get ML people in general for years, and we still are to a degree. And MLOps people is even worse, right? Because there's even fewer. Yeah. And there's something to do with it being a new thing, but also I think there's a lack of candidates in the market who meet the bar, and by the bar I mean someone you could reasonably ask and expect to do a good job. There's quite a lot of people applying who think they know what it's about, and when you then speak to them, it becomes quite clear that they don't. It's often out of academia. It was very similar when we started with just plain ML engineering. We had exactly the same problems, but I also think a lot of the problems come from that there's a lack of quality material on the subject. So most of the talks and most of the tutorials and most of the certifications and presentations and all of this are incredibly narrow and focus on one particular stack and problem. It's usually how I solved a incredibly narrow data science project on a specific data set that only that person has access to, on a particular cloud that they're using at the moment, with the technologies that were popular at that particular moment for that sort of stack. And I think we need to focus more on general principles so that we can have people learn about MLOps practices and general principles, rather than being locked into a specific stack and then finding that employability becomes difficult after that, because although it's fairly transferable, a lot of employers will go, well, do you know AWS or not?
Okay, gotcha. And what is it, going back to what you said about, lots of people will apply and they'll think they have the skills and the knowledge to be specifically an MLOps engineer. What is it that makes the difference between those that just think they can do it and those that actually do meet the bar, do you say?
I think it's having done it. So that's a bit of a chicken and the egg problem, right? But
Yeah.
if you come to me as someone who's just graduated and you say you want to do MLOps, that's great. I tend to hire more on cultural fit and attitude than how much you technically have done. But if you've never ever actually made a model and tried to deploy it, then you have very little experience with the problems that arise from trying to do that, right? And the least you can do is follow any tutorial. Ideally, you find something that you're interested in and try to do some ML thing related to that, but you don't have to. Choose literally any tutorial, any course, follow it, and actually try to deploy it. You don't have to make an expensive model. Deploy it onto, participate in a, what are they called, the challenges? Why have I forgotten that now? There's a site. Yeah. Participate in the 𝐋𝐞𝐭'𝐬 competition. You don't have to have a great result. Just show that you did the work, right? And then link it. Or, put it onto a very cheap host. Like you can get free instances now on most of the cloud ones, and you don't have to make a giant model. Just make it with some small, tiny data set. Like CFAR is entirely tiny. The diabetes training set is entirely small, right? Like choose something that will produce a fairly small model and then actually deploy it. And then try some of the MLOps principles that you've heard about in the buzzwords around the place, right? Like try some of those things and then put it on your GitHub so that I can see it, and provide your GitHub link on your CV. Do that.
Awesome. That's pretty solid advice, to be fair.
Yeah, that's the main difference.
Yeah.
Aside from that, it's entirely possible for someone who's worked in the ML space for a while but hasn't specifically worked in the operating side to be able to do that. There's not like some hard barrier, right? It's more that when I speak to people in an interview, it becomes quite clear quite quickly that they haven't even thought about the problems before. And it's very hard to think about the problems unless you are tackling it. So I'd recommend people go and do that if they want to pursue it.
No, thank you. That's great advice. And are there any that you haven't mentioned, sort of specific skills that the machine learning engineers should learn that may be different from, I mean, there will be many roles, right? They may come from data science or machine learning or, developing, but are there any real sort of key skills that you would say MLOps practitioner or specialists need to have, they must have, that must be on their list?
So I think it's maybe useful to think about where you're coming from there. So if you, there's two very common paths into the ML space in general, but also MLOps. One is from an academic background, not necessarily that you're in academia and you've just graduated, but maybe you've mainly been working on the science tasks for a company, right? And you're now wanting to get into the engineering side. For those people, I think focusing on very just basic engineering principles, not ones that are specific to MLOps, just make sure that you are comfortable with version control systems and that you know a little bit about crafting software. There's a bunch of resources on the internet about this. There's nothing specific in general that I'd recommend. Just like focus on getting up to speed on engineering principles. Most of the people who work in the science side of things are very smart people, so you usually only have to tell them that there's something that when you're trying to build stuff together as a large company, there's certain tools that we usually need for that in order to not have too much chaos. They tend to understand that, and then they go off and learn it perfectly well. That's usually not a challenge. It's more about spending the time getting to know those principles and those tools. The other very common path in is if you come from a software engineering background, right, and you're trying to break into the science side of things. And there, I would say that there's probably slightly more requirements for you to be successful, which is you're going to have most of the engineering down, I would hope, most of the engineering principles, and you'll be able to transfer most of those. I'd say that statistics is quite important because as part of your day job, you will be looking at what models are doing. And when models go wrong, it can be quite subtle. So you need to be able to identify that, and even if you don't and a scientist flags it, you need to be able to understand why and how do you fix it, or whether you need to get involved. You don't need to understand how the model works end to end. That is usually a more sciencey colleague of yours job, but you need to understand enough to understand whether the model is doing what it's supposed to be doing, and why it might have gone wrong, and whether you need to get involved, whether it's something you can help with. And having good statistical knowledge there is quite important. It also features into when you're going to be part of deciding whether a model gets published out there, right? Because you're part of the model release control process probably, or at least the tooling that deals with that. So when a challenger model comes along, how do you decide whether it's good enough? Or if it's worse, if it's okay to still release it because it has more recent data, for example, and that's more important. You need to be able to judge that, and without stats knowledge, that's difficult. You need to also be able to say to your stakeholders things about statistical significance of like a test. So when you're doing an A/B test, for example, the signal needs to be higher than the noise, right? Otherwise you can't tell whether it's effective. And if you don't know how that works, it's very difficult for you to do your job effectively. Aside from that, it's great if you just, start getting into all of the different kind of model types there are, how they usually map to particular kinds of problems that tend to come up, so that you know which sort of model would we typically use for which kind of problem, and what do those architectures usually look like, and how would you normally deploy those architectures. This is something that will take quite a long time, and I suggest that you start with whatever model or project is in front of you. But I would recommend taking courses. I can recommend some courses. It depends on what kind of learner you are. So if you're a top-down learner, then I recommend Andrew Ng's course on Coursera, which is the Machine Learning Engineers Specialization, or whatever it's called. I think it's just Deep Learning Specialization. That one's really good. It teaches you all of the theory top-down. If you are less of a top-down learner and more of a bottom-up learner, you like to know how things work, you like to get your hands dirty, then the video series by Fast AI is great. What they do is they go through many different kinds of very common models or model types that we tend to come into contact with, and you build them from scratch. And then every time that you've built some feature that you would normally have in a framework, then you get to use the framework's version of that. So you don't have to do it, all of it. But it gives you particularly if you're an engineer, it's a great way of understanding how do machine learning architectures actually work nowadays. Yeah, those would be the advice. If you are not from academia or a science background and you're not a software engineer, I would recommend you get one of those degrees first, or get not a degree. It doesn't have to be a degree. No one really requires those anymore. It's more about what you've done, but get into projects that get you hands-on experience with those disciplines. It's very easy to build software nowadays. Do some of that. It's very easy to do machine learning 101 tutorials as well. Just do some of those. And
I've even done some of those. I've done, yeah.
Yeah, and pay attention to the space. I'd say if you want a cheat for how to, get up to speed quickly, not just with machine learning, but with tech in general, read Hacker News. It's 𝐻𝐤 news.𝐻𝐤combinator.com. It's a Silicon Valley centric forum that sort of like posts a bunch of news every day, and the top 20 is pretty good to have a look at. They won't all be ML. There'll be a lot of different tech stuff there. And don't just read the articles, actually read the comments. The comments are way better because you're getting some of the really, really good Silicon Valley engineers and engineers from around the world, because it attracts all of the good engineers, commenting on technologies that are emergent and how the current state of technology is today and how we're doing engineering. And it's a lot of ML material on there, and the comments are often better at summarizing it and giving you good perspectives on the article that's been posted.
Thank you. That's really great suggestion. And then sort of we talked about the roots and the key skills then, I guess, of an MLOps engineer. One question I have is in your opinion, where then should an MLOps engineer start to get involved? But then where should they stop? So like there's lots of talk about cross-functional engineering in teams, but let's say for organizations that maybe don't have that luxury, what should they be able to bring to the team? What's realistic to ask of them, and where are you asking too much or not the right things maybe?
This is very context dependent. So in a startup, you're probably all hands on deck and you're going to be doing a lot of everything. In a large organization, you'll have a very specialized role. I like to think that it's useful to think of ownership boundaries, and I don't want to create artificial silos or anything like that, because then that leads to the typical throwing over the wall problem where scientists make a model and they throw it over the wall and then the engineers have to figure out what to do with it. You don't want that. Cross-functional teams are great and that's what you should strive for. But if you can't do them for whatever reason, ideally an MLOps person, their ownership boundary is the infrastructure and how nice, easy, and reliable it is to interact with the models. That's what you should be focusing on, whatever leads to that, as opposed to the success of the model. So that is a scientist's job. A scientist should be interested in the success of the model, which means they should also be involved in the entire journey. They shouldn't just, oh, I've made a model now, it's somebody else's problem. You don't want that. You want your scientists to all of the way be interested in the progress of their models that they're having success. But as an engineer, you should be focusing on the infrastructure, that it's reliable and that it's easy to interact with, particularly for whoever your downstream is, if you will. I also think it might be useful to think of it. There's a famous diagram that gets thrown around a lot in pretty much all MLOps presentations nowadays. It's from a paper, but you can find it in an article by Google called MLOps, Continuous Delivery and Automation Pipelines in Machine Learning. And if you can't find it there, the original paper is Hidden Technical Debt in Machine Learning Systems. And it's this sort of like block diagram where you have machine learning code in the middle as this tiny box. And then you have all of the tooling and stuff that goes on around it as all of the other boxes. And that sort of illustrates like, why do we need MLOps? Or it's because machine learning code is actually a quite small part of the problem in shipping machine learning solutions. And what should you be doing as an MLOps engineer? Like you should do everything except the middle box.
Okay, that's good. That makes sense. You can sort of visualize it in that way, Awesome. Yeah. Thank you. And then, I mean, you are lead MLOps engineer, as I mentioned before. So then in terms of that, do you have any tips for leading or running MLOps teams?
Sure. I think one thing, there's a few that are like easy, I can just rattle off, but I think one thing that at least organizations get wrong quite often is not giving enough time and support to your team and their learning time. This is, again, a very fast moving field. And even if you are on top of your stuff, usually you're only on top of a very narrow thing that you've done before. And there is a very large breadth of things going on in our field. So I would say make sure that your team, not just you say that they have the time and resources. So if this costs money to take courses, you need to provide that, and you need to make it easy, and you shouldn't ask people to pay up front. It should be taken care of by the business up front so that people don't have to spend their own funds, and make that smooth. But also people should feel like they have the time. A lot of the businesses say, yes, this is important to us, and then they squeeze you whenever there's a deadline and you never feel like you have time to invest in your own learning and upskilling. So that's pretty important. I'm a big advocate for diversity. I think when you build your team, you should try to get a very good spread of people from very different backgrounds. And I don't just mean ethnically, gender-wise, that's also a good idea. But generally from what types of ML they've done, and which sort of businesses they've been. You want people from a startup, and you want people from a big corporate working together, and you want people from deep learning and reinforcement learning and traditional ML all working together. And even within those, there are sub branches, right? You have generative stuff versus image, like like big language model stuff and stuff like that, the more perspectives you can get in the mix, the better your team's going to do overall. So diversity is a big one. I think also treat it like a product. So we like to say it's an intelligent product or a data product, right? Because if you don't, you'll find that you'll probably struggle to ship something good. And what I mean by that is the focus will be on make the model, and then the scientists will stop caring. And then it becomes engineering cares about deploy the model, and then engineering stops caring. Whereas what it actually should be is a product where all of the bits work together nicely, and the journey of integrating with your downstream, which is often a front-end team or something like that, right? It should be nice for them so that they feel like spending time out of their backlog, prioritizing, getting your product out there. Like treat it like a product is a good motto to go by. And with that, like I just said, be a good citizen in your shipping ecosystem. You want both your upstream and your downstream to feel like you are allies, not someone to deal with, because then your job will become really difficult as well. We talked about ownership boundaries. That's one of the points I was going to tackle under there. There's some common dysfunctions, which I guess I can say just maybe don't do those. Common dysfunctions that I see is artificial boundaries and silos, where like we have a science team and we have an MLOps team and we have an ML engineering team, whatever. Just don't do that. Try to do cross-functional teams. You'll do way better in the long run. And try to have the scientists do as much engineering. Don't force them to do engineering. They should spend their time where it's valuable, which is not engineering tasks, but they should be able to contribute, and they should be aware of engineering principles so that they can work well with the engineering team. And likewise, the engineering team should try to branch as much into science and build their knowledge as much as possible so they understand how they can make the journey good for the scientists, right? So don't like go out of your way to create boundaries, and that is often created by creating different teams, or your organizational structure works against you. So that's something to keep in mind. Another one is don't gatekeep the disciplines. So a lot of the time it's like, no, engineers can't do science, or scientists are too sloppy to do engineering. Like those are very common attitudes. Just don't do that and challenge it whenever it comes up. Everyone should be able to do both. This should be interdisciplinary. Make sure that the disciplines are equally valued. So one thing that I often see is that you might have a function that initially started off as science-led. That's very, very common that we go, oh, we must do AI, so let's get the people who know how to do the algorithm part, right? And then those tend to become entrenched, and then they tack on engineers afterwards. And then for some reason, we never look at how the org should look like, or we never rethink, management lines or anything like that. And often you end up with one side or the other feeling like they're not quite heard or valued. And that leads to a lot of problems. So make sure that everyone is heard and feel like they're equally valued. Don't just say it. Make sure that they actually feel like they're equally valued. Yeah, that's about it. I guess there's one tip on recruitment. So everyone struggles with recruitment, right? There's not enough people. It takes forever to hire, and it's really hard to know what the good candidates are, and there's not enough good candidates, and everyone struggles with this, right? If just for building the engineering side of your ML team, a senior lead or just senior veteran ML engineer can take some junior engineers and bring them up into mid-level way faster than you can hire that number of mid-levels usually. So what I see is a lot of organizations going, we need mid-levels, we don't want juniors, or we need seniors, we don't want mid-levels and juniors. And then they go out and they realize that the FANG companies have poached all the good ones, right? And they can't compete on salary. That's basically what happens with most companies who aren't FANG. So what are your options? Well, you can keep looking forever and then not having the resource to do all of the things you'd like to do, or you can dedicate some of the time of one person that you may be able to get hold of, or maybe already has, who is a veteran in the field, and give them some people who've just graduated or who've done like their first startup job or something like that, and bring them up. That will be, in most cases, as far as I can tell, way faster than trying to hire the equivalent role. Maybe not into senior, but I think there's still a pretty good path there. I think you just need to throw more challenges at your mid-levels faster, and then be open to progressing them faster within your organization. That means don't have any artificial boundaries on how fast you can progress, right? That's a pretty good recruitment hack.
No, that's a great tip. No, that makes sense as well. I suppose people probably think less to not, I mean, it is looking internally, but also to just bring them and then bring them up. Like you said, that's a really great tip. I think we've got time for one more question.
Sure.
It's a big one. Well, it's an exciting one. What for you is the most exciting thing happening right now, either in MLOps or just even in AI in general? What do you feel really passionate about? What are you excited to see how things develop over the next few months? Yeah, one or two,
Sure. I mean, everyone's very taken by generative AI at the moment. So ChatGPT or any of the GPT variants.
Yeah.
I'm less of a fan of OpenAI because they aren't open and they charge. I like open source, and so in my private projects, I'm very into the image part of the generative AI. So your DALL-Es, your Stable Diffusions, and those. I'm a much bigger fan of Stable Diffusion because it's completely open source and the data set is also open source. And it actually runs on consumer hardware. So you can run it on your gaming machine if you have a good enough graphics card. You don't need to rent something in the cloud to do it. Obviously, something like Colab notebooks does get you around that to a degree. So those I'm very excited about those and how we can use them, how they will change industries. I know there's a lot of controversy around. Some artists are feeling a little insecure about their jobs. I would say to them, we can't build those models without your work, so I wouldn't worry. The AIs don't work unless we take the human art and put into them. So I think you're safe for a while.
It does put into question their role, though, doesn't it? Long term, sort of, what will the role become? I used to be a translator, and my role, the role of translation has changed largely from actually doing the translation to just proofreading machine translated text, which I don't mind, but I feel like in the sense of art, that does put their role into question, doesn't it? What's going to happen? What changes will be made?
Yeah, I think it probably won't change that much. Stock art, for example, will probably change quite a lot, but I don't see it as very different to, I think Tim Cook of Epic Games, the CEO of Epic Games, had a pretty good take on this, which even before he said that was sort of my thought on it, which is, remember when Photoshop got brushes and you could do all of these amazing things with brushes that you weren't actually doing yourself?
Yeah.
It's not really that different. It's just another tool in your tool belt. I also think that there's not enough consistency in the theme and subject in what we can currently do with those for them to be super useful in a lot of settings. So one of the big things that we've been thinking about is gaming, right? Like the production of a game and all of the assets that go into that. Usually within a game, you want to have some consistency in the theme. That's a little difficult at the moment, and particularly if you want to have the same character but in multiple different settings or poses. You can play with the seeds to a degree, but then it's not so straightforward. It's a bit of an art with prompt engineering at the moment. So I'm not too worried about that just yet. I more see it as a superpower for indies, right? So tiny game studios that has one person who only knows how to code and can't really draw, right? That person is now incredibly empowered to, enact their dreams, if you will. And that's part of what excites me. That's, I guess, the one thing, and that's on a lot of people's mind at the moment. The other one I wish was more on people's minds is ethics and its implications in legislation. I think not enough people are talking about ethics in AI, even within the discipline. I think we need way more awareness about it. And I'm excited and anxious to see at the same time where that will go, because ethics and legislations aren't necessarily going to be the same thing. And we know that typically legislation is always very far behind, right? And we've already seen it go wrong quite a few times where it was easily avoided. There was a case, for example, in the US where a AI system was being used to recognize faces on CCTV footage. So a lot of people were wrongfully sentenced by this system. And it turns out the reason that is that it misrecognized their faces. And the reason for that was that the AI system itself, the data set that it had been trained on was massively imbalanced. We know that, we don't know whether it was ImageNet that it was trained on, but we've known recently that ImageNet is quite unbalanced. It turned out that the data set that this system had been trained on had only like white men in it. So obviously it is very bad at recognizing just about anybody else.
And it was being used professionally, just only on that. Okay.
And people were being sentenced like wrongfully based on this, right? So, and I think anybody looks at that and goes, well, how did the people who are building that not realize that this would be a problem? Because everybody understands class imbalance in their data sets. That's fairly basic.
Yeah.
So I think it's awareness that like you probably need a bit of a checklist, maybe to remind yourself before you send something out there that, you know, go through how could this go wrong, right? And you know, maybe raise some alarm bells or some flags if that is the case. And this is
that can change. This is life changing, right? This can change. It's not a mild inconvenience. That's changing someone's trajectory of life based on that. So, you know, it's very, you know, it's essential that it's right.
Yeah, and again, think about how it's very easy to see how wrong this can go with things like insurance companies and your bank, right? And when they start to get their hands on data sets about you that are quite maybe invasive, right? When there are breaches and leaks like we have all the time, right? And your data gets out there and they learn about you, and then suddenly you get declined for your credit card or your mortgage or your insurance or whatever, because they know something about you, and it's this, you know, model that maybe hasn't been entirely vetted for the ethical concerns, if you will. And one of the things that I'm both excited and also anxious about is how does this develop? And where I see it featuring into MLOps is eventually we're going to have legislation, even if it will lag, and it will probably not be great legislation immediately, although in the EU, we've had pretty decent legislation for things around privacy laws recently, so maybe it won't be too bad. But that legislation doesn't really mean anything unless you can enforce it. And we know that very typically a lot of models aren't very interrogatable. So it's very hard to like look at them and go, okay, why are you doing this wrong? Can I explain why you're doing this wrong? And can I stop you, right? A lot of the time the answer is remove the data that's problematic for some particular individual, like right to be forgotten, for example, and then retrain the model so it's not there, right? But I also think we're going to see a lot of tools spring up, paid or not, I don't know, around interrogating models for ethical concerns and compliance with legislation in the ethical space.
Okay. Fantastic. Thank you so much. And that's all we have time for, I'm afraid. So again, for like the 10th time, thank you so much for sharing your time, your knowledge, and all of these really exciting topics for the present and for the future. Thank you to everyone watching as well. I really hope you enjoyed today's chat, and see you soon. Bye-bye.
Thank you. Bye-bye.
Let's end with a little bit about Logic. At Logic, we recruit specifically within the machine learning engineering and research fields in the UK, Canada, and the US. We pride ourselves on our innovative, community-led approach and having a deep knowledge and understanding of the roles that we recruit for. That's one of the reasons why I've started this podcast. If you're looking for your next professional challenge, or on the other hand, you might be an organization looking to expand your machine learning team, then please feel free to connect with me on LinkedIn and send me a message. Alternatively, you can send me an email to becky@logic.com. Let's set up a call for a chat, or we can meet in person for a coffee.